For the function below, use the second derivative to find where the function is concave up and concave down, and we need to find the inflection points. So there are three things here that this question is asking for: where the function is concave up, concave down, and the inflection points. So the first step will be to find the first and the second derivative. So step one, find the first and the second derivative. So the first derivative is 6x squared minus 6x minus 12, and the second derivative is 12x minus 6. And once you have those, we can proceed to the second step, which is setting the second derivative equal to 0 and solving for the potential inflection point. So step 2 will be set second derivative to equal to 0, and solve for the potential inflection point, and solve for the potential inflection point. So which means we take our second derivative, equate it to 0, which means 12x will be equal to 6, which means x will be equal to a half. And this is where we suspect there is a point of inflection. So what I need to do next is to use the sign diagram. Okay, sign diagram. So step 3, use sign diagram for the second derivative to check for change in concavity around the inflection point. So use sign diagram for the second derivative to check for change in concavity. And in fact, as we check for change in concavity, we'll be able to know where this function is concave up or concave down. So here is our x value, which happens to be a half. Now, what you're interested in is the signs of the second derivative, which means we need to pick some test points. So if we pick, for example, something that's the left of a half, so 0, what are we going to get? If we pick something to the right of a half, so for example 1, what are we going to get? So you plug this into the second derivative, which is that guy. What do we end up with? So if we plug in 0, we end up with negative 6. We plug in 1, we get up to 6. So that's a negative, and that's a positive. With what does this mean? So this means that concavity changes at x is equals to 2. Concavity changes at x is equals to not 2, a half. Hence, there is a point of inflection. There is an inflection point. In fact, where it's positive, that means that's concave up, and where it's negative, it's concave down. So we can actually answer that question here. We can say that concave up, we know that's concave up when the second derivative is greater than 0, which means when x is greater than a half, okay, on our sine diagram. And concave down, when the second derivative is less than 0, which means when it's negative, when x is less than a half. So that answers part of the question. So when it's concave up and concave down, now we need the inflection point. We know that the inflection point is when x equals to a half. So we need to find the y coordinate, which means that will be our step 4. So step 4, find the y coordinate. So which means you plug a half into the original function, this one. And if you plug in a half, you'll end up with negative 13/2 or negative 6.5, which means that inflection point is a half, or inflection point is at, okay, is at a half, negative 13/2.